Today we are talking about coterminal, reference, and special angles. Coterminal angles are two angles that share the same terminal side, which means the same ending line. So, for instance, in this case, this is a 30-degree angle. So we start at the initial side and it's positive, so we're moving counterclockwise to 30 degrees. But a coterminal angle for this, I'm actually giving you two examples. So we could have started off at the initial side and just gone a whole extra circle around. So in this case, if we move an extra circle around counterclockwise, what we've done is we moved another 360. So really we're just adding 360 degrees to your already existing 30 degrees. And so this is 390 degrees. So whenever you're moving counterclockwise an extra circle, you're really just adding 360 degrees. So 390 and 30 are two coterminal angles because they both end up on the same line. This one has just moved an extra circle. So we could also move a circle around clockwise. So let's say instead of moving counterclockwise, we start at the initial side and move clockwise to the same line. In this case, you're going to be subtracting 360. So since we're moving clockwise now, this is a negative number. 30 degrees minus 360 degrees gives you negative 330. And so that's what this angle is. So all of these angles are coterminal because they really look the same at the end. It just depends on how you get there. So let's look at number one. So if we take a look at the degree 500 angle, so we're starting at the initial point, the initial side, which is right here. And to move 500 degrees, we're actually going to go around at least 360. Right, so after 360, if you wanted to go another 90, that would be 450. So we're going to go past this one. And then we want to go 50 degrees past that. So it's going to be up in the second quadrant. That is a 500-degree angle. Now to find a coterminal angle, we're going to both add 360 and subtract 360. So if we were to subtract 360 from 500, that would give us 140 degrees. So that's one coterminal angle. If we were to add 360, that would give us 860 degrees. So that's another one. So here are two coterminal angles to 500 degrees because they will both end up on the same line. 140 just goes around one time, right? So it starts here, just ends right there. 860 is actually going to go around twice before it goes to this line. Okay, let's look at 60 degrees. So with this negative angle, we know that we're going to be moving clockwise. So we're going to be moving in this direction. 60 degrees is about right here, not quite to 90. So this is negative 60 degrees. And to find two coterminal angles, we're going to start with negative 60, and let's first subtract 360 degrees. This gives us negative 420. And we can also add 360 degrees, which will give us 300. So here are two coterminal angles that again will end at the same place as our negative 60 degrees. So now what if we have radians? Pi over 4. So we know, again, here's my initial side. We know pi over 2 is 90 degrees, so pi over 4 must be halfway there, so around 45 degrees. Alright, so this is pi over 4. In the same way that we did it with the degrees, we want to go a whole extra circle around. So this time, because we're in radians, instead of adding and subtracting 360, we want to add and subtract what 360 degrees is in radians. So what is an entire circle in radians? It's 2 pi. So we want to add and subtract 2 pi. So if we're subtracting 2 pi, because it's a fraction, we're going to need to rewrite this as a fraction with a denominator of 4. So let's multiply by 4 over 4, which is going to give us 8 pi over 4. All right, so we're just going to rewrite 2 pi as 8 pi over 4. So then this is 1 pi over 4 minus 8 pi over 4. 1 minus 8 is going to give us negative 7 pi over 4. So this is one of my coterminal angles. I'm going to do the same thing and add 2 pi, which again is 8 pi over 4. And 1 pi over 4 plus 8 pi over 4 is going to give us 9 pi over 4. So just like with the degrees, we've just moved an extra circle around, an entire rotation around, either counterclockwise or clockwise. So we're adding and subtracting 2 pi. Okay, let's look at negative 2 pi over 3. So here's my initial side. It's negative, so I'm going clockwise. So if we're splitting our pi up into 3 pieces, so this is pi, we want to split it up into thirds. So this is 1, this is 2, this is 3. Then 2/3 would be right here. Alright, so this is what negative 2 pi looks like, or negative 2 pi over 3 is right here. This is 2/3 of pi. So again, to find my coterminal angles, I'm going to be subtracting 2 pi. So 2 pi, I want to rewrite it with a denominator of 3. So if we multiply by 3 over 3, it's 6 pi over 3. So again, this is really, we're just subtracting 2 pi, but I've rewritten it as 6 pi over 3. This is going to give us negative 2 minus 6 is negative 8 pi over 3. And we want to do the same thing, but now adding. So again, we're adding 2 pi, which in this case is 6 pi over 3. We need the denominators to be the same. Negative 2 pi plus 6 pi is 4 pi over 3. So here are my two coterminal angles to negative 2 pi over 3. So let me box these so you all can see. Those are the coterminal angles. So that's how you find coterminal angles. Now we're also going to talk today about reference angles. So this is something that's going to be very important to us as we move on in our later lessons. This is the smallest positive acute angle determined by the x-axis and the terminal side of theta. So really what we're looking for here is we want to find an acute angle to the x-axis. So you want an acute angle to the x-axis. So once we start drawing these, this will be easier to see. So the first thing we're going to do is draw this angle out in standard position. So this is 150 degrees. So here is my initial side. 150 is going to be in between 90 and 180, a little bit closer to the 180, so it's going to be about right here. And so I move counterclockwise. This is my theta, which is 150 degrees. Now we're looking at the terminal side. So the terminal side is this one right here. And I want to see what acute angle I can make with this and the x-axis. So the x-axis is this one right here. The acute angle that this forms is right here. Alright, so that is my alpha, which is your reference angle. It's the acute angle formed between the terminal side and the x-axis. To find this, so I want to see what is the difference between right here and right here. I'm going to subtract, so this right here, this line is 180 degrees. And I'm going to subtract the 150 degrees to find out what I have left in between them, which is 30 degrees. So my reference angle here is 30 degrees. Let's look at number 6. So let's first draw 315. So again, I'm starting here. 315 is going to be between 270 and 360, so it's going to go all the way around to the 4th quadrant. And this is my theta, which is 315. So now your alpha is the acute angle that this right here forms with the x-axis. So in this case, here is your reference angle alpha. Because if I were to make it to this x-axis, it wouldn't be acute anymore. So it has to be this one. And to solve for this reference angle, so this one is closest to the 360. So 360 minus this angle, which is 315, gives us what's left over in between, which in this case is 45. So my reference angle here is 45. Now with radians. So 4 pi over 3. I know that this is pi. If I were to be counting thirds, This would be 1/3, 2/3, 3/3, so 4/3 would be about right here. So this is my theta. My reference angle is, so this terminal side is closer to the negative x-axis, which is right here. So that's the acute angle. Again, it doesn't go to over here because that would be obtuse. And for this one, my reference angle is, so this is 4 pi over 3. I'm going to take this and I'm going to subtract right here, which is pi. So I'm going to say, what is 4 pi over 3 minus pi? Again, I need my denominators to be the same. So I'm actually going to turn this into 3 pi over 3 so that my denominators are the same. And this is just going to give you pi thirds. So pi over 3 is your reference angle. Now pi over 6, so again, this is pi. If I were to divide these up into sixths, so 1, 2, 3, 4, 5, 6, then it would just be in the first one right here. So this is my theta, pi over 6. And in this case, the reference angle is actually the same thing, because this is the closest to this part of the x-axis. So your alpha is the exact same thing. It's just pi over 6. So as you can tell, there's different ways of determining the reference angle depending on what quadrant it's in. So if it is in the first quadrant, so if your theta is in the first quadrant, your theta is going to be equal to your reference angle. Right? It's going to be the same thing. If it's in the second quadrant, so if this is my original angle, my reference angle is going to be right here. And in this case, depending on whether or not you are in radians or degrees, you're going to either subtract 180 minus your original, or pi minus your original angle, depending on degrees or radians. For both cases, you start here and subtract the original angle. Now, if you are in the third quadrant, so here is your original angle, your reference angle is this part right here. And so in this case, you're going to be starting off with your original angle and subtracting either 180 or subtracting pi, depending on if you're in radians or degrees. Lastly, if you are in the fourth quadrant, your reference angle is this part, which means you are either going to be subtracting from 360 or subtracting from 2 pi. Oh, excuse me, this is theta. So either 360 minus theta or 2 pi minus theta, which is your original angle. Okay. So let's take a look at some special angles that are going to be really important for us to remember. So special angles are the multiples of 30, 45, and 60 degrees. So let's just start off with the degrees. Right here is, of course, 0 degrees. So with this first circle right here, this is split up into 45-degree chunks. So this is 45 degrees, this is 90. We can keep on going around. So we're just adding 45 each time, 135, 180, 225, 270, 315, and then back around will be 360. That's all the way around the circle. Now if we use radians to label this, so again we're starting off at 0. 45 degrees is the same thing as pi over 4 radians. 90 degrees is pi over 2. So these are each of these chunks is 1/4 of a pi, 1/4 of a pi radians. So this is pi over 4, this is 2 pi over 4, which is pi over 2. Over here is then 3 pi over 4. So each time we're just adding another pi over 4. If we added another one, it would be 4 pi over 4, which is the same thing as pi. If you add another one, it would be 5 pi over 4. This one would be 6 pi over 4, but 6 over 4 is the same thing as 3 over 2, so 3 over 2. 6 pi over 4 over here is 7 pi over 4. And then finally 8 pi over 4, which 8 over 4 is the same thing as just 2 pi. So each of these sections, we're just adding another pi over 4. For this next one, now this is split up instead of into fourths of a pi. So this is my entire pi right here. This is now split up into 1, 2, 3, 4, 5, 6 pieces. So this is going to be pi over 6 instead of pi over 4. We're again starting off at 0 degrees or 0 radians. So if this is 90 degrees, also pi over 2. We know that this is split up into 3 parts, so this must be 30 and this must be 60. And as we just said, this is also pi over 6. If we added another pi over 6, it would be 2 pi over 6, but 2 pi over 6 is the same thing as pi over 3. Alright, so 2 pi over 6, in case you need to make that note. If we added another pi over 6, it would be 3 pi over 6, which 3 pi over 6 is pi over 2, if you simplify it. So our next one, we're going to be adding 30 degrees, so this is 120, and adding another pi over 6. So if we add another pi over 6, now it's 4 pi over 6, which is the same thing as 2 pi over 3 when you simplify it. Let's add another 30 degrees, so now it's 150. If we add in another pi over 6, this now turns into 5 pi over 6. We add another 30 degrees, and another pi over 6, which is now 6 pi over 6, which is the same thing as just 1 pi. This is 210. We're adding another pi over 6, so now it's 7 pi over 6 in radians. This is 240, and 8 pi over 6, when you simplify it, is 4 pi over 3. 270 is now 9 pi over 6, which is 3 pi over 2. 300 is 10 pi over 6, which is 5 pi over 3. And then 330 is 11 pi over 6. And finally, we're back to 360, or 12 pi over 6, which again is just 2 pi. So those are all of our special angles, multiples of 30. And then up here were multiples of 45.